Inverter.
Welcome to clickmyprojects.com.
Here we are going to discuss about improve the performance of LRU page replacement algorithm using augmentation of data structure. A good approximation to the optimal algorithm is based on the observation that pages that have been heavily used in the least few instructions will probably be heavily used again in the next few. Conversely, pages that have been used for ages will probably remain unused for a long time. This idea suggests a reliable algorithm. When a page fault occurs throughout the page that has been unused for the longest time, this strategy is called LRU, that means least recently used paging. Although LRU is theoretically realized, it is not cheaper. To fully implement LRU, it is necessary to maintain a linked list for all pages in memory, with the most recently used pages at the front and the least recently used page at the rear. The difficulty is that the list must be updated on every memory references. Finding of a page is a list. Deleting it and then move it to the front is a very time consuming operation, even in hardware. However, there are other ways to implement LRU with special hardware. Let us consider the simplest way first. This method requires equipping the hardware with a 64-bit counter C that is automatically incremented after each instruction. Furthermore, each page table entry must also have a field large enough to contain the counter. After each memory reference, the current value of C is stored in the page table entry for the page just referenced. When a page fault occurs, the operating system examines all the counters in the page table to find the lowest one. The page is the least recently used. Now let us look at a second hardware LUT of LRU algorithm. For the machine with n page frames, the LRU hardware can maintain a matrix of n and acute n bits, initially all zeros. Whenever page frame k is referenced, the hardware first sets all the bits of row k is to 1, then sets all the bits of column k to 0. At any instant, the row whose binary values is lowest in the least recently used, the row whose value is next lowest is next least recently used, and so forth. The working of this algorithm was given in our following details. Here in this, we using first in first out technology by the help of pipelining architecture to allocate the page management in a memory by using LRU page replacement algorithm. Now I am going to discuss about flow diagram of our project. In the first stage, we get the initial address points and enabling from CPU. From the CPU memory, it gets the first load in the virtual memory cases. So for the first stage, we get data from the memory addresses for writing the given data into the internal memory from the CPU. Then this was provided into physical and virtual addresses. Then according to the virtual addresses, it checks the virtual memories and update for each and every instruction data. The updated files are first initially get address information. After the virtual memory instruction, it gets the address information and estimate the page sizes. In the page sizes stage, it checks each and every locations according to the page and arrange it in linked list position. From the linked list position, it checks the details about every updations of chained structure of the linked position and arrange it in series structure. According to the arrangements, it checks priority of the page to store the data of the given from CPU. Then after that, each and every arrangement, it checks whether the page was 0 to n. For each and every pages, it forms as a cluster. From the forming of clusterations, it updates for each and every clusters, and these updations was provided in the virtual memory states. Then the final allocations cluster formed was found in the allocated page. This allocated page was restored in the address information stage. Then finally, from the allocated page, we write the given data. Then from at the read position, from the address informations which are located in virtual memory, this was fetched at the output stage, and we can read the memories of data from the virtual memory. This was fed to the output. Now I am going to explain the running procedure of our project. In this stage, we run RTL schematic diagram, technology schematic diagram, and finally we have to display the timing diagram of our proposed work. In the first stage, we check the errors which are provided in the codings by run check syntax. This will display any other errors or warnings which are present in our coding. Here we use VST format of coding to design our architecture design. Now we view the RTL schematic diagram by run the RTL schematic, view RTL schematic. In this stage, it displays the logical circuits of our proposed architecture designs which are placed in our codings. Then now click add and click create schematic. This is our overall schematic diagram of our proposed work. We can view the internal structure of our proposed work by double click in. This is our RTL schematic diagram, internal structure of our proposed work. This displays the logical diagrams of our total architecture. Now we can view the technology schematic diagram by run view technology schematic. Now click add and click schematic. This is our overall technology schematic of our proposed work. Now we can view the internal structures by double click it in. This is our overall architecture diagrams for technology schematic diagram for our proposed work. This displays the LUT based structures. Then we can view the timing diagrams by click simulation and click the main function, then run simulate behavioral model. In this stage, it displays the timing diagrams which are each and every structures of our proposed codings. This displays the signals and inputs and output pins details. Here we display it in iSim simulator. After that, we give the input for each and every stages. Here I give the input and output buses as our proposed values. For each and every input stages, we give any data, either 0 or 1. So in this, the I representing input data, the CLE represents clock enable. At the initial stage, I give the clock enable as 1, and the ALE, I give the initial output as 1, and clock enable CEN, I give initial value as 0. Then for read enable, I give as 0. Then for write enable, I give at the first stage as 1. Then for writing in the page, I give the value as 1. Then select enable and for input value. Now click the run with the time specified on the toolbar. So after the stage, it will display the RYBYN structure outputs. So now we can change the clock CEN value. has changed to 1. This will be updated for each and every stages. Thus, according to that, our page allocations will be made at the output. Thus, we allocate the page by using our LRU page allocations algorithm method. Thank you.